Hello, in this recording we're going to talk about solving over a given domain. Now, if you came here looking to solve equations and you've been doing this for a while, you know that we don't normally think about solving over a domain. So this is kind of a weird little side question in the whole topic of solving equations. And the idea is this, that we are going to give you a domain. We're going to say this is what x is allowed to be. Get my pen to work here. There we go. There's all the numbers x is allowed to be. In fact, let me just give you a little rundown of this. So that says x is an element of the uh, the set of numbers that includes 0, 1, 2, 3, 4, and 5, which means that those are the only things x is allowed to be. Those are the only numbers we're allowed to use, and we're not even going to solve this in kind of a normal way, normal algebra way, which we will do later. We are going to just plug these in and see if they work. So we're going to take our equation, 6 plus x equals 11 is the first one, and we're going to just write, we'll do it like this, 6 plus 0 equals 11. And does it equal 11? Well, you know the answer is no, it does not. Okay. Now that's a little bit tedious, so I'm going to go with just one color for the rest of these. 6 plus 1 equals 11. No, it doesn't. How about 6 plus 2 equals 11? 6 plus 2 is 8, so not 11. 6 plus 3 equals 11. Nope. 6 plus 4 equals 11. Again, it does not. 6 plus 5 equals 11. Bingo, there it is. That's the one that works. And so we say the solution is 5. And we can write that with our little set notation. So the solution set is 5. We could say x equals 5. So we'll typically say x equals 5 if there's just one solution. If there's more than one solution, then we'll use set notation and put all of the solutions together in one set. That's the little braces there with commas in between the different values for x. So in these ones, we're only going to have at most one solution, so we won't have to worry about that too much. Let's try the next one. So this one says 5x equals 10, so this is a multiplication problem. So 5 times 0 equals 10. No, it does not. 5 times 1 equals 10. No, it doesn't. 5 times 2 equals 10. Yes, it does. Now, we might be tempted to stop here, but technically, because equations could conceivably have more than one answer, correct answer, more than one correct value, we can't just assume that that's the end. We have to check all of the numbers in the solution set, which is, kind of tedious. We know the rest of them aren't going to work, but we have to check anyway, certainly at least mentally, because you never know when you're going to run into an equation that has more than one solution. But none of these ones work, and so we stop. We say, therefore, the solution set is the set that includes the number 2, or we could say x equals 2. Let me write that correctly. X equals 2. Okay, let's do this one up here with the fraction 1 half x equals 2. This is another multiplication problem, right? It's 1/2 times x, but 1/2 times something means the same thing as divide that something by 2. Cut it in half. So 1/2 of 0 is 0, not 2. 1/2 of 1 is 1/2, not 2. 1/2 of 2 is 1, not 2. 1/2 of 3 is 3/2, 1.5, whatever, definitely not 2. 1/2 of 4 is 2, that's true. And 1/2 of 5 is not 2, it's 5/2 or 2.5. So once again, we have our solution set of x equals 4, and there we have it. And again, just to reiterate, I'm giving the answer in two different ways. The first way I've been doing it with the little set notation is more appropriate when there's more than one correct answer. Most of the time, we'll use the just x equals notation here because that's in general, as we start out here, we're looking for one solution to these. Okay, let's do the last one real quick. X divided by 3 equals 2. Now let me say a few words here, or just one quick word about the idea that you're probably yelling at the computer screen here right now and saying, I can do these ones in my head. I know what the answer is right now. Why do I have to write this out? And the answer is, I know, it's frustrating, but we're learning this concept or this idea of having to choose from a group of numbers, and very quickly we will get to the idea of having a problem and coming up with the solution all by ourselves from all the numbers, not limiting ourselves to a specific set of numbers. But you can imagine a situation where you might have a problem where you limit yourself to a certain number of solutions. Let's do this one. Okay, so we said divided by 3, so x divided by 3, so 0 divided by 3 is 2. Nope, it is not. 1 divided by 3 is 1/3, not 2. 2 divided by 3 is 2/3, not 2. 3 divided by 3 is 1, not 2. 4 divided by 3 is 1 1/3, not 2. 5 divided by 3 is 1 2/3, not 2. And then we stop. We're done. We've run out of possible answers. Now this one is frustrating because you know the answer is x equals 6. But if you know that, then you're wrong. Because the question said, and this is way back up here at the top, the question said, if x is one of these numbers, which number makes this equation true? And the answer is none of those numbers make that equation true. And there's a way to show that or to say that none of those numbers, none of the legally allowed numbers will make our equation true. We do it like this. We draw this circle-looking thing with a line through it. That's called the null set. And it's the set that includes no elements, nothing in it. It's different than 0. 0 is a number, but the null set is the set that contains no numbers. No number, it's 0 numbers, yes, but 0 is a number, so it's not 0. It's nothing. So this is our statement saying there is no legally available solution to this equation. in this particular instance. And there you have it. By the way, I'll just point out, we don't say x equals the null set. That's not the way we say this. Please don't do that. It's just the null set. The null set kind of corresponds to the set notation where we say here's the set of all the numbers. The null set is a set. It's the set that contains nothing. The null set could be written like this if you wanted to. Nobody does this, but it's the set that has, look there, what's inside there? Nothing. So that's the null set. Okay, that's it for this video. Thanks for watching.